Okay, good evening, guys, and you are welcome to the class. This is a general course, CIT 104, regardless of your department, what you are studying, you will have to do this practical course that teaches you the appreciation of computer, how to use the computer, what the computer is all about. So this is the course you should love naturally yourself as a person, not because the school is wanting you to do it, but you should be excited about the course. You should have a lot of enthusiasm about it because basically in this our world today, there is no profession you find yourself that the knowledge of computer and the especially the operation of computer is not valuable. There is no department, no profession you find yourself that the knowledge of computer will not be an added advantage to. So, guys, just as a form of introduction and a form of reminder, because this is how we've always started this class. We always start by reminding ourselves that this course is a practical course, number one. And what we mean by it is a practical course is that you are going to have a part of the course that deals with practical, which means you will need to visit the practical center. There are some states and centers that have been designated for practical activities, for courses that have practicals. Not all study centers have practical lab, or sorry, the laboratory in their centers. So you need to visit the nearest to you. For people living in Lagos, you are not traveling to anywhere. People living in Abuja, you are not traveling to anywhere. People living in Oshun, you are not traveling to anywhere because right there in Oshobo, you have a practical center. People living in Port Harcourt, you are not traveling to anywhere. But people living in other states like Ekiti, like even people living in Kano, you don't need to travel to anywhere. So there are some states that don't have practical center, I mean the lab. So you need to visit the nearest state to you to do the practical. Now the practical is very easy. You will be uh, taking practically on how to use Visual Basic 6 application, where you will know how to manipulate it, how to use it, the things you can do on it, and they will practicalize it there in the lab for you. It's advisable you go with your own laptop, because not because the school doesn't provide laptop, but those of you that will go to centers like Lagos, like even Abuja, the population used to be very, very much. So the laptops available will not be sufficient to serve everybody, every participant. Therefore, it is advisable that you come with your own personal laptop so that you will be able to participate effectively, because it's a practical thing. You have to install the application on your own system too. You have, although we will do that here too, we will teach you that here too, so that when you go to the practical, it's just like they are revising. Notwithstanding, you need to try your best. It's not that if you don't have a laptop, you cannot do CIT 104. Please, let's learn that. Don't go and be disturbing your parents, or you yourself you go and collect loan because you want to buy a laptop. It's not like if you don't have a laptop, you can't do it. You can do it. It means you should go early so that you use the one provided by the school. But it is advisable if you have your own personal laptop already, go with it. So that is number one. Another thing is that, excuse me, the practical aspect is the life of the course. And I will do well in the exam. I will just try my best in the exam and score like 50. So I know I have C already, because you are deceiving yourself. If you go to the exam and score 70 over 70 in that course, once you miss the practical, your result will come out as incomplete. I hope you guys learn from this set. You saw the way we had so many issues on the result, so many issue of incomplete. Although there are a lot of biases from the school itself, because not everybody that got that incomplete failed to attend the practicals. Most of them, they attended the practical and also did the exam, but that was just some issues from the school. And you see that they've eventually rectified it. So you need to attend the practical, do the assignment very well, and submit, because they will give you an assignment in the practical section which you need to submit. That assignment you will submit serves as a TMA for that course. It doesn't have TMA on your portal. When you log in, when TMA start now, you will not see any TMA on that course. Even if you see TMA, if you click on it, nothing will show because there is no TMA for that course. So no TMA, but the practical section will serve as a TMA. So what you score in practical will be added to what you score in exam. The two combined together will form your overall grade in the course. Don't joke with the practical. Don't copy your friend in the practical. The side effect of copying somebody in the group of 100 students solved the assignment, then the rest of the 99 copy the same thing and submit. What will happen is that some people will get good grades, some will be given F. Why? Because once they see repeated assignment, like the repeated version, it's obvious that all of you copy each other, not that everybody solved the assignment individually. That leads to malpractice or a form of F. They will give you F automatically. So be careful. Those are the things you need to know about this course, please. Your practical is the life of the course, not even the exam. Not that you should not do the exam too, but you see that practical, if you don't do it, you're as good as getting incomplete in the course. So that is all for that. What we have tonight is the computing environment. That was where we stopped in the last class. Now, when we talk about, we've been talking about a lot of things in this course. We've talked about brief history of the computer. We've talked about what a computer is. We've talked about data. We've talked about information. We've talked about methods of processing data, the manual, the mechanical, and the computer method. We talk about the advantage of the computing method. We talk about the characters of the computing method, like the speed, the accuracy, and so on and so forth. If you guys remember, I think we used a mnemonym then to hold those characters so that we will not forget them. So we've done all that in this course already. Now we're moving to something else, which we call, in fact, we have also done hardware and software. If you remember, we said that the computer system is divided into hardware, software, and we talked about each of them one by one, what falls under each of them. Now we are going to what we call the computing environment. Having known what a computer is, the part of the computer we have, the one that is software, the one that is hardware. The next thing is for you to know where you can operate the computer, or where a computer is being operated is where we call the computing environment. Now let's read a bit. The computing environment includes the building housing the other element of the computing system, namely the computer and the users, the furniture, auxiliary devices such as the voltage stabilizer, the uninterrupted power supply system (UPS), the fans, the air conditioners, etc. Now, anything at all, when you enter an office that uses computers, everything you find in that environment, including you that you are operating the computer, including the fan, including the table, the chair, everything that exists in that environment where computer is being operated is collectively called the computing environment. So you have so many things: the user, the furniture, the auxiliary. If you have AC there, if you have fan, if you anything at all that you can set your eyes on and identify as existent in that place is a part of the computing environment. What is the UPS? The UPS serves like a power holder. Like if you connect your, the desktop is such uh, a machine that the moment the power fails, that means the moment the NEPA takes light, it's off automatically. It does not retain power, it does not save power. So you need UPS, a computer connected to the UPS If NEPA just take their own light now, boom, the computer will still remain on. It will now be serving on the power that is stored in the UPS. UPS store electricity. So if the UPS battery is strong, it may serve the computer for like maybe an hour. So for 1 hour you can continue using your computer even when NEPA has taken light. We're not talking of laptop, but that one they used to put on desktop. That's the one that looks like television. That one too. So it now serves like battery. Does the work that battery is doing in a laptop. That is the work UPS does. So and the full meaning of UPS is the uninterrupted power supply system. So the schematic diagram of computing system is presented below. Now, these are the things we are going to see in the guys. It's like we've done this place. You guys should remind me. Oh, we've done this before, please. I think there is an error here. We are actually supposed to. Oh, okay, okay, okay. We've not done this. Don't worry, we've not done this. We've not done the schematic diagrams, but we've read about all the rest of them, like the hardware, the software. Yes, I understand what is happening. So they want to use diagrams to show everything we have done in this unit. Let's start with the computing system. Look at this diagram that talks about computing system. The computing system on its own comprises of the following: hardware, software, the users, and then the computing environment. And if you remember what we have done in this unit, we've talked about each of them individually. We've talked about the hardware, the input, output devices, and the processing devices. If you remember, we talked about the software, the system software, the utility software, the application software. If you remember, we've talked about that too. Then the users, where we have professional users and casual users. Then the computing environment, the one that comprises of everything that you can find in a place or in an office or in a room where computer is being operated. So this is like the main topic. Then they were all divided into subcategories because when we studied them, we talked about different things. Under software, we talk about system software, just like I mentioned earlier. We talked about utility software, we talk about application software. Excuse me. Then, for example, system software, we have the operating system. That is the meaning of this schematic diagram. It's very simple to understand. It's just everything we have done in this unit that they decide to use a diagram to present to us as a form of summary. Now, under utility software, we have something like antivirus is a utility software. Scan disk is a utility software for scanning any external thing you plug to your computer, like your memory card that you plug to your computer, like flash that you plug to your computer. Then for application software that are used to do set of uh, specific works, we have word processor, your Microsoft Word, that you use for what? Handling document manipulation, like typing, editing document, copying, and doing anything on document. We have spreadsheet, which is Excel. We use for broad calculation, even for programming, for database and anything, for data analysis. Excel. And like it's just that we are not serious with this. We made a decision during the holiday that we'll try our best to do extra classes, like extra courses on these applications. Like I will teach you everything about Microsoft Word so you become a certified office user, like somebody who can do just anything. You can type magazine, you can type books, you can type anything once you know how to use Microsoft Word. We promised ourselves that, but till now we haven't come to an agreement of when to start and how to go about it. Maybe you guys should go and hold a personal meeting and tell me the perfect time to learn that. Every skill you learn today puts you on a higher chance of employment or of even earning more income tomorrow. So every skill you are learning today becomes a source of income for you tomorrow, whether you like it or not. Let's not waste any opportunity, especially anything that relates to the computer is not lost. You will eventually make use of it. Now we have another example under application software, the statistical packages. they are used for statistics and the rest of them. So those are examples. What we're just trying to do with this schematic diagram is just to show you a kind of a form of recap of everything we have done in this unit. So we have under the computer software, we have computer users as the last part under the computing system. The computer users, no, sorry, no, not the last. We still have the computing environment. Now let's talk about the computer users. If you remember that when we were talking about computer users, we mentioned some set of users that are professionals, those that even program the computer. We call them expert users. They can do anything on the, they can manipulate the computer, they can turn the head of the computer upside down. Those are expert users. We have end users. End users are people who, like, if you have a business center now, you can print, you can type, you can edit, you can use Photoshop, you can, those are, yeah, those are, they are under all end users. Then we have casual users, gamers. I just bought it for me to type my final year project. I just want to be watching film with it. I just want to be listening to music with it. Those are casual users. So then under the expert users, we have categories. The categories we have under expert users, we have system engineers, programmers, computer operators, and then data entry clerks. Those are people that falls under the computer expert. After that, we have the computing environment. The computing environment. What are the things you find in the computing environment? We have the building, the furniture, and okay, we have the building, the furniture, and auxiliary devices. Those are the three things you find in the computing environment. But under auxiliary devices, those are things that are not attached to the computer, like is not part of the main component of the computer. Like, you know, when we talk about computer, we're talking about the monitor, the one that looks like the TV. We're talking about the mouse, the keyboard, the CPU. You understand? Those ones are main part of the this thing. But the ones that you just the format, they are kind of attachment to make your operation of the computer better. Those ones are auxiliary devices. That is what we have UPS to. So having done all this, we can conclude on this unit. This unit has been so enriching. We learned a lot. The meaning of a computer, we learned data and information. Oh, sorry, yes, data and information. We learned data processing method. We talked about mechanical, we talked about manual, we talked about computing, we studied computing method, we talked about the characters of the computer method, using computers to process data. What are the advantages? What are the characters? We studied it. Then we move to the computer system, where we talk about the hardware, the software, and the users. So we talk about quite a lot of things. We talk about the computing environment also. Then under the hardware, we talked about input and output devices, and then the processing devices. Under the software, we talk about system software, utility software, and application software. Under what is it called? The computing environment, we talk about the building, the auxiliary devices, and users, everyone that you can find around the computing environment. So the conclusion, the computer is a machine used for a variety of purposes. Its use transcends all areas of human endeavors owing to the advantages of the computer method of data processing over the manual and mechanical method of data processing. So guys, having done this, we can summarize this unit. But before we summarize, I have some questions I want to ask you as a form of icebreaker, because I have been talking and talking and talking. So UPS, what's the full meaning of UPS? Okay, I can cite a question here asking me what is the work of who? Data entry clerks or something. Okay, I think we mentioned that under end users. We mentioned data entry clerks under end users. Well, just like their name implies, data entry. You know what who a clerk is actually, but what is the data entry is what is confusing you. But they are the one that enters data accurately. Like for instance now, let me give you an example. The people that keep updating student record every semester, that we have new set of admission processing. The people that keep updating that, okay, we have 100 and or we have 2,000 new students this semester. The name of this one is this and this. The matric number is this and this. This was the date we admitted the student. The people that update the data like that time to time, they are the ones we call data entry clerk. They input data, new record, they update existing record. Now Dora was in 100 level first semester in the last semester. She's moving to second semester now in this semester. There are some people that are in charge of updating your record from the first semester to the second semester, which is a new semester entirely. That is updating a updating data that was already recorded. And they also maintain database to make sure that the result of Dora was not the one they show for Grace when they release result. You see, the issue we had in the result of this semester, that people that did practical did not get result they were putting complete, was because of improper management or lack of management entirely of the database. So they also retrieve information. For instance, if Dora on the site enters her, or probably let's not even use site now. Dora goes to school, and she wants to uh, get maybe a statement of result, or probably in her place of work they ask her to bring something, maybe the day she maybe admission letter, and then no copy was found in the house. She had to go to school. So it is the data entry clerk that will go to the database on the shelf and start looking for Dora's record, bring it out and do what she wants to do on it. So that is the work of data entry clerk. They have a lot of work they do, but their work involves around data. And the person that will be a data entry clerk must be fast in typing. So I think let me stop there. I'm already giving you guys too much on data entry clerk. That is not what we're here to do tonight. So in summary to this unit we have learned the following: that the computer is any electronic device that can accept data, process it, and produce an output. Another thing we learned is that the computer method of data processing is superior to the manual and mechanical methods of data. Well, that one is obvious. We know that in the manual method it was so slow, it was stressful, and the rest of them. The mechanical was also stressful and hazardous because of it also make noise. So the last one is that the computing system is made up of the computer system, the users, and the computing environment. Now I have a classwork. The classwork is, what is a computer? So that is an icebreaker. I will wait for you guys to answer the questions one by one in the chat box. The first question is, what is a computer? That is what we've learned in this course. The second one is advantages of the computer method of data processing over the manual and mechanical method. That is, and you must answer it. Then the last question says, draw a schematic diagram of a computing system and describe each of the components. Well, you can't do that in the chat, so that one will be a question for homework later. So that brings us to Unit 2. We have successfully gone through Unit 1. Now we are free to go to Unit 2, which is the history of the computer, a historical overview of the computer. Uh, Please, you guys will permit me. Just continue answering the questions and give me a few minutes, please. Okay, so we are going into the history of the computer. So, a historical overview of the computer. What, how did it start? What was the first thing that was, developed that later transformed into more development and then more development and more development until we eventually arrived at the computer we are using today. In this unit, we'll talk about a lot of things. The first one is a brief history of computer technology. We move to first generation of computers, I mean electronic computers. This unit is what you've learned in unit one of your GST 103 in last semester. So if you read that material very well, you will find this unit as a kind of revision. First generation of computers, I mean the electronic computers, occurred in 1937, that is in the 1930s to the 1950s. The second generation occurred in the 1950s to the 1972. The third generation, I think there is an error here. It should be 1960. There is an error here. That 72 should be 63. I think they will correct themselves later on. It should be 1954 to 1963, and then from 1963 to 1972, 1972 to 1984, 1984 to 1990, and 1990 to date. That is the sixth generation. Those are the things we will learn in this unit. Where tonight we should be able to do brief history of computer technology. Maybe from the next class we'll then move to first generation, or if we still have the time to study the first generation in this class, fine and fine. So, introduction. The computer as we know it today, has evolved over the ages. An attempt is made in this unit to present in chronological order the various landmarks and milestones in the development of the computer based on the milestone achievement of each era. The computer evolution is categorized into generations. The generalization classification, the generational classification, however, is not rigid as we may find one generation eating into the next. So, what are the things they want us to know in this unit? Why do we want to read these stories, this history? Why is it necessary? At the end of this unit, you should be able to do the following: explain the processes leading to the emergence of the modern computer. What they want you to know is that here is a computer that you are using today. How did it came to be? How did they come about this machine that we are using today that is now common everywhere? Every house now has one. How did it start? Was that how they started? The first time they started the computer, did they produce laptop? Did they just produce plenty laptops and then they started selling it from that time to now? Was that what happened? How did we come about this computer? You should be able to explain and give in details that knowledge by the time we are done with this unit. And the second thing they want you to know is that to be able to predict the direction of research in computer technology in the near future. You should be able to say that in the nearest future we have a laptop or another type of computer, maybe a palm top or any kind of top that will be able to do this or do this. Since from the beginning, the first one was only able to do calculation. Then they started moving on and started doing the one that can do more things, that can do more things. And before you know this, they started doing the one that cannot think like human being, that cannot even behave like human being. So you should now be able to use the knowledge of the history you have to predict the future of computer. So two things here: know history, then use the history to predict outcomes in the future. Those are the two things you must learn in this unit. Which means at the end of this unit, if you cannot predict what will happen to the computing world in the nearest 10, 15, 20 years, then you still need to go back to this unit and and retrace your steps. Now, a brief history of computer technology. A complete history of computing would include a multitude of diverse devices, starting with ancient Chinese abacus. Well, in case you don't know that abacus was from China, you are just learning now. So we have Chinese abacus, the jacquard loom. The jacquard loom was in 1805, such a long time ago. And then we have the Charles Babbage analytical engine For Charles Babbage, we call his own invention analytical engine. Even from the name, you should know that it's an engine that deals with analysis. So 1834. It would also include a discussion of mechanical, analog, and digital computing architectures. I hope you guys know that there was a time that television that you are watching today was in form of a box that you'll be tuning a knob like this to get station. It doesn't have color. You put one long antenna outside. That was when the thing was still analog. So there movement from mechanical to analog, and from analog they move to digital now that we're using. Now you see that every digital thing you are seeing today, they had analog version of them. They had the time that you can only operate them mechanically. You can only use your hand to operate them. Look at the time they were using land phones before they invented hand phone. You can call that one analog, while the hand phone is now the digital aspect of it. So we have, so the digital computer you are using today did not just start from digital. It started from something weird, something that if you look at it then you say, ah, how is this thing like this? Just the same way when they started doing even the digital computer too. When we started having desktop that you put on desk, you can't move it around. It was since then somebody envisioned, or somebody visioned that, ah, if we already have this, why don't we have something that we can be carrying around? That is what they are saying, that once you read the history of computer tonight and you fully understand it, something should enter into your spirit. You should be able to say that, okay, if that is how it started, with things with manual or with mechanical devices, and then they started developing them, and then eventually got to analog devices that were, those ones are better than mechanical, and eventually they felt that we can even add color to this thing. We can even do it to start working on its own. We can even do it to, they start, then they move to digital. It means that if they were using desktop before, and somebody came up with laptop, and then another person said, this one too is still big, it's still somehow stressful. What if you produce palm top that you can now carry on your hand and just be operating? Or what if you produce tab? That is how they started moving and moving and moving. So computer was now becoming more digital and more digital and more digital. So you too can now think of, okay, since we're having something as small as a tab now, or a palm top, why don't I, okay, can't we have something more, even more crazier than that? You'll be able to predict the future. That is what you will learn here. So as late as the 1960s, this is where I am now. Don't forget that we said that it all started with things like the Chinese abacus, the Charles Babbage analytical engine, the Jacquard loom in 1803, and so on and so forth. Now, as late as the 1960s, mechanical devices such as the calculator still found widespread application in science and engineering. Now, during the early days of electronic computing devices, we are just going to read this place, it's history, so open your mind. During the early days of electronic computing devices, there was much discussion about the relative merit of analog versus digital computers. So I own company of producing computers can develop laptop. Let's see how it's going to look. It's a welcome idea. Now, during the early days of electronic computing devices, there was much discussion about the relative merits of analog versus digital computers. In fact, as late as the 1960s, analog computers were routinely used to solve finite difference equation arising from oil reservoir modeling. That was their main focus then when they developed the analog computers. I have another you guys on that statement. We've started icebreaker now, so be ready to type. So in the digital computing devices proved to be sorry, to have this is where I'm reading, to have power, economics, scalability necessary to deal with large scale computations. So digital computers now dominate the computing world in all areas, ranging from the hand calculator to the supercomputer, and are pervasive throughout society. Therefore, this brief sketch of the development of scientific computing is limited to the area of digital electronic computers. What we're trying to say is that there was a kind of debate, a kind of quarrel between analog and digital computer. Eventually, digital computer won the race, and now it's now what we are using everywhere. Nobody will want to go to market now and go and buy analog computer, because how do you want to give yourself headache when there is something that can operate smoothly and enjoy the operation digital? Why will you decide to go for analog? It's just like when they say you want to build a house now in an estate, you can't say because your grandfather said that this bricks, what this one that they use, what's the name of this soil to do, this clay soil, you now say it's clay bricks that you want to use and build your house. So out of the houses we have in the city, in the estate, your own house now look like a house that a bird or maybe an animal built, because you decided to stay analog when all your mates are already digital. That is what they are trying to say. Digital has won the race and is now everywhere. Everybody now embraces the digital world. So, sorry for going back. I have a question to ask you guys. I have a question to ask you guys. So let's go back to where we are reading. I have jumped to first generation. Where we are, we said that digital has won the race. Another uh, another icebreaker, another icebreaker there for you guys to attempt. Now, the evolution of digital computing is often divided into generations. We know that the evolution of digital computing is often divided into generations. Now, that is why we'll start talking about generations of computer. Now we've known about digital computers, you know that we have three sets that have passed, or two sets that have passed, the mechanical and then the analog, now the digital. Now, each generation is characterized by dramatic improvement over the previous generation in the technology used to build computers. Why do we have first generation, second generation, third generation? Is because the first generation they built, they find a lot of lapses and improvement that are needed. So when they improved on it using another system of building the computer, they formed second generation. Second generation was still not satisfying enough. They had the need for improvement. They started improving by rebuilding using another system. That moved them to third generation. That one too was still lacking something. They built another one again. They call it fourth generation. That one too was not sufficient enough. They built fifth generation. And even fifth generation was improved a bit to form sixth generation. What is the difference between each of those generations is that they use different technologies to build the system. Now, as a matter of fact, the internal organization of computer system also differs in those generations, and then the programming languages also differs in those generations. Let me tell you something funny. In the first generation of computers, if you are not a programmer, you cannot use a computer, because they use codes to talk to the computer. Then now that you open your laptop, pa, 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 you have type English, pa, 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 the computer will answer you, give you response. It wasn't so before. Then if you don't know about coding, sorry, you won't even go near your computer. It was like an idol then. It's only those who are priests of that idol, that means programmers, that will be able to operate. We'll get there when we are talking about first generation. So although not usually associated with computer generations, there has been a steady improvement in algorithms, including algorithms used in computational science. The following history has been organized using these widely recognized generations as mileposts. So, since you already know that we had transition from mechanical to analog, and then from analog to digital, and then during the world of analog and digital there was a lot of race or races then on which one is better, which one is sound, until digital eventually won the race and now became the talk of the town. Then the digital computers started having generations of improvement from first down to sixth. Our main concern now, or our next concern in this course, is to start talking about each generation one by one. What makes each generation unique? What was the technology they used in each generation? What was the lacking, the deficiency that they found in each generation that made them want to improve it to a next generation? We will learn all those as we start studying the generations of computer. We have just finished a brief overview or history of the computer. So, what's the time? We have 3 minutes left. I have an assignment to give you guys. You guys should submit it to Dora. This assignment is okay. Let me say, oh, excuse me, I'm typing your assignment. So, Dora, please handle that assignment. That is the assignment. Everybody should submit it to Dora, the class captain. That is the homework. I'm interested in this assignment. If you do not do every other assignment I've been given, make sure you submit this assignment. I'm going to take a drastic action on those that refuse to submit it. This is a general call, so everybody in the group, whether you are doing mass com or not, you are expected to submit it. Write an essay to support or oppose. That means you can decide to say analog is better than computer, or you say digital is better than analog, any way you twist it, but just either support or oppose it. The topic is digital computers are better than analog computers. So if you are opposing it, your own will be analog computers are better than digital computers. So that is, having done this, I think we have done justice tonight. We finished unit one, we moved to unit two. We started talking about the overview of the history of the computing, of the computer world, and we've talked about that. And the next thing we'll go into is the generations of computer, where we'll talk about first generation down to the sixth generation. We'll make sure we cover all that in the next class. Thank you all for attending the class tonight. I hope you enjoy the rest of your night. Stay safe. See you guys tomorrow. Hold on. Today is Wednesday. I hope you guys don't have a second class today. Those of you in mass com, do we have a second class today? If you have, say we are not taking it today again because we started this one late. If we are meant to hold a second class, then that one will be tomorrow. We'll shift it to tomorrow. For now, enjoy your night. Bye bye.